Hello and welcome. We are turning our attention now away from simply quadratic equations, which we studied for quite some time, and now we're going to look at the more general case of polynomial functions, of which quadratics are one example. So as you can see here, it looks a little crazy and scary with all the stuff that's going on here, but remember that we're using the letter A to stand for any real number. And so A sub n just means the first one. You know, when n, the lead term when n is 1, that's the first one, and the second one, all the way down to the last term, which is the constant. So a polynomial function is basically something that looks like this. The degree is the highest exponent, which is in the lead term. And then this lead coefficient also has a role to play, as you'll see when we look at these in more general terms. But so this is going to be called the lead coefficient. This is called the dominating term because it's the one that determines what we call the degree of the function, which is the highest exponent. In general, we call polynomials of degree n, linear, quadratic, cubic, etc. This thing right here is always the constant term. There is no variable component to it, it's just a plain number. It could be 0. And then what we also know to be true of any polynomial is if that I evaluate any polynomial at 0, which is to say I plug in 0 for the value of x, this number right here is all that's left. All the other terms drop out, and so that is the initial value, or the y-intercept, just like we saw with linear graphs. Even if x is 0, there's still going to be, if there's a constant term here, a place where the graph touches the y-axis. So some characteristics of polynomials. First of all, they are always continuous. So that means if you were to draw the graph of a polynomial, you could always do it without ever having to lift up your pencil. Polynomials have no sharp corners. They have no, they do have turning points, but they're not vertices as you would find on a polygon. And so this is really important right here. A polynomial of degree n can have at most n factors. Therefore, that basically means it can have n roots, which means solutions, zeros, and lots of other. We have several ways to refer to these things. And then, of course, the last point down here, a polynomial of degree n may intersect the x-axis fewer than n times. So it doesn't have to have n x-intercepts, but it will have a certain number. It will have, according to the fundamental theorem, which we'll study later, it'll have n roots, including complex conjugates and so on. But not to get too far ahead of ourselves. So let's talk about a real basic function here. Here's an example. And when we talk about these, we want to talk about three things in general. We want to talk about whether or not, or how many, I should say, turning points a polynomial has in its graph, how many zeros it has, which is to say solutions. And that's also what we call, lastly, end behavior. So how does this polynomial behave as we move, as x gets larger and larger as we move toward positive infinity or toward negative infinity on the left? So here's an example. Here's a linear function. We studied these quite a bit earlier this year. This has 0 turning points. It's obviously, by definition, never going to turn. It's a straight line. It's got one x-intercept, or 1, 0, and its end behavior, is that it's going up on the left and down on the right. This is partially because it has a positive slope. Now, if I looked at this other one, this is also a linear function. It has no turning points. It has one root, 1, 0, one solution. However, in this case, we say that the end behavior is that it's going down on the right and up on the left. And this is because it has a negative slope. So as x gets larger and larger and larger, this graph moves farther and farther away from the origin, and it goes, the y value gets lower and lower because of that negative slope. When we studied quadratics, and you remember, let me undo that, try to change the color. Let me erase it then. Black, so we'll use black, sorry. So we studied these quite a bit. You remember that this is an example of a quadratic in which the lead coefficient a is positive. That's why it opens up. This one has just one turning point, the vertex. It has two solutions, 2 zeros. And its end behavior is that it goes up on the left and up on the right, and that again is because A is positive. If I look at another quadratic of the type we also studied, in which my lead coefficient is negative, that's a little too steep there, that's almost vertical, so that's no good. This again has one turning point. It has 2 roots, zeros, and it also has end behavior such that it goes down on the left and down on the right. And that again is because A is negative. Now what we're about to get into, we're about to start looking at polynomial functions that have a degree that's higher than 2. We spent a lot of time studying linear and quadratics. Now we're going to look at cubics and beyond. So an example of a real basic cubic function would be one that looks something like this. And again, I really wanted to use black for the picture. Sorry about that. And then I'll talk about features. So this one's a little different because it's got 2 turning points. They're kind of shallow in the way I sketched it, but sometimes they can be more extreme. They've also got 3 zeros. The degree is 3 and the number of zeros is 3. Not a coincidence. And lastly, the end behavior, sort of as we saw with a linear, is it's going down on the left but up on the right. We could also look, the degree is still 3, but maybe the lead coefficient does something different. Perhaps we could look at a cubic like this one. This one's again got 2 turning points. There's a turning point, there's a turning point. We'll study these later and identify them as local maximum and minimum values. We've only got one real solution, but as you'll learn, we actually will have 3 solutions. Just only one of them is a real number. And our end behavior, up on the left, down on the right. So one more example to look at, another new is one called a quartic function, degree 4. And in this case, quartic functions do things like this. Not always exactly like that, but, and again, my sketch is pretty vague and pretty rough, but now we see 3 turning points, and we see 1, 2, 3, 4 real solutions, 4 zeros here. And again, just like with quadratic, the end behavior is up on both sides. Quartic function of the type I just drew, but the lead coefficient is negative. I still have my 1, 2, 3 turning points. I still have my 1, 2, 3, 4 solutions. In this case, all 4 are real numbers. And now my end behavior goes down on both sides. So hopefully you're starting to notice there is a pattern to all of this stuff. What the pattern is, you know, if we look at this example, which is a cubic, this is an example of a cubic function, we see end behavior that goes up on the left and down on the right. We see 2 turning points, and we see 3 real roots. So cubic means degree 3, and in this case that gave me 3 roots, it gave me 2 turning points, and the end behavior was up on one side and down on the other. So when we talk about just the end behavior and the turning points, what we see here is that if it's an odd degree, let me erase that a little, didn't mean to make that, I was trying to move it. If the degree is odd, that means that it's going to do different things on each end. It's either going to go down on the left and up on the right if the lead coefficient is positive, or it's going to go up on the left and down on the right, and that's when the lead coefficient is a negative number. But what you'll notice about odd polynomials, whether it's cubic or quintic or 7th degree or above, it'll always behave differently on the 2 ends, and that's because the degree is odd, as compared to even degreed functions, which will always do the same thing on both sides, just like we saw at length with quadratics. Positive opens up, negative opens down. And what we should have seen, hopefully you noticed that the number of turning points will always be 1 less than, or at most 1 less than the degree. It doesn't have to have that many, but it couldn't have any more than that number. So that's just a basic intro to polynomials. We're going to study them quite a bit. We're going to solve them and graph them and do lots of fun things. You guys are going to love it.